We're going to work with tables of data similar to what we did back in chapter 1, but this time we need to know if our data is linear, like it was back then, or quadratic, like we're focusing on now, or maybe it's neither one. So the way to do this, if you have an idealized table of data versus a real world problem, is to look at the first difference in the y values. If the first difference is the same between every single pair of values, then we have a linear function. If not, we will move to the second difference, and if that's the same, we have a quadratic. The other thing that we need to keep in mind is before we do any of this, we need to check the difference in the x values to make sure that those are constant to start with. Because if those aren't constant, then we can't do this technique. So looking at our first example, number 5, the time in seconds, I can see that I'm going up at a constant rate of 1. I have 1, 2, 3, 4, 5, 6, 7. So every time I move from right to left, I'm going up by a positive 1. So that part is good. Now let's look at our first difference. So first difference means that we take the difference between the second number and the first, so 416 minus 424, and I get a negative 8. 376 minus 416, negative 40. Continue doing this for all of the values, and you can definitely see that our first difference is not the same number. We're going up and up and up in negative numbers here, ending with a 136 when I take 64 minus 200. All right, so we are definitely not linear. Let's go ahead and look at our second difference, because this will tell us if maybe we are quadratic instead. So the difference between negative 40 and negative 8 is negative 32. Negative 72 minus a negative 40, which is like a plus 40, also negative 32. If I continue along here, I see that every one of these is a negative 32. Don't assume that just because the first couple work out that the rest will work out. You have to check each difference individually. All right, so my second difference is the same, which means that I do have a quadratic. See, if the second difference is the same, it's quadratic. Why don't you try the next two, number 6 and 7, and see what you come up with, linear, quadratic, or neither. Come back here to check your work. Okay, example number 6. You should have noticed that each of these values in the x are going up by 3 at a time, so we do have that increase that's the same each time. So we can do this method. Our first differences came out to be negative 6 across the board, and if the first difference is the same, we are linear, so you should have chosen linear for this one. Number 7, I'm going up in increments of 1 in my x, so that means that I can use this method. And now I can see that my first and second differences, neither one of them was a consistent value, so we are actually neither. Spoiler alert, this one ends up being exponential, but we won't talk about that until next semester.